In this video, we're going to be working through the start of Chapter 10, though we are going to be making some of our own additions for some concepts that actually carry across both Chapter 10 into our chapter on personality. So we're going to start by talking about psychometrics and then working our way into intelligence. So psychometrics first, which we'll talk about what it is and why it's something that actually bridges across multiple of our topics. Then we're going to get into intelligence, what it is, and a little bit about the history of intelligence testing. Then we're going to get into how we conceptualize intelligence, how do we think about it, what models do we have, things like that. And then we'll get into a bunch of factors that influence intelligence, which will also include things like where do we see differences, what kinds of patterns do we observe, and what do we know about what actually drives that. So all of that to come, but we are starting with this concept of psychometrics, which, as I said, is not exclusive to intelligence, but intelligence testing is a field that falls within the umbrella of psychometrics, and therefore it's a great spot for us to take a pause and actually talk about this field and why it's important and how we can use it. So this is all about measurement and description of different psychological constructs. And this is going to stress a bunch of stuff that is not new to this class. We've already talked about the fact that within psychology, we have to be really cautious about how we talk about things because oftentimes we're working with fairly abstract concepts. So how does that relate? Well, psychometrics is specifically a field of psychology that's focusing on measuring and numerically or statistically describing different kinds of psychological constructs. So it is especially focused on trying to objectively quantify abstract and or covert abilities. So at the very beginning, when we talked about what a behavior is to a psychologist, and we said it really matters on the individual, some of our stuff is going to be a lot more overt in terms of abilities and behaviors, stuff that's easier to measure and quantify. But in psych, there are also a lot of concepts that we're going to encounter that are much more internal or covert, things that it's really difficult to directly observe. So things like intelligence or personality, where you don't have something external that's going to be quick and easy to say, yes, this one thing shows us your intelligence. It's a lot more complicated than that. And so that's the focus of psychometrics, is trying to figure out how the heck we can look at these more abstract concepts and try and describe them and use those measurements in a way that's useful for our understanding. So clearly, main areas are going to include things like intelligence and personality, but this can also get into things like measuring achievement or performance. Even things like aptitude tests can fall under this field as well. So there's all sorts of things that can tie to psychometrics, but we're going to find that one of the biggest unifying factors about psychometrics is they care an awful lot about standardized tests that are going to allow them to collect tons and tons of data. So if we're wanting to understand these very abstract and hard to quantify concepts, we need to figure out how we can measure those abstract concepts. We want to try and capture different dimensions that might be related to those concepts. So there's a lot of sort of loose terminology here, and I'm going to try and give you examples of what exactly I mean for each of these by relating it back to usually intelligence or personality. But we're basically saying that there's some big ability, something like intelligence, and we want to figure out what makes up intelligence. So are there things that we can measure that help us understand how intelligent someone is? How do we quantify that? So usually we're going to come up with ways to try and measure these things and look at those measurements. And once we have a model that allows us to start interpreting some of those measurements, we can start comparing new individuals to those models based on whatever our measurements are. And I guess to clarify here, the first point is basically saying we need to figure out a model for our understanding of intelligence. And the second point saying once we have a model where we know that these things, these measures are related to the ability that we're interested in, we can actually use that model and apply it to new people where we can get somebody to take a particular test where we know what their scores are going to be if they have certain abilities or if we know the strength of their abilities, and then we can interpret that and make use of that. So this would be something like when we're setting up, we want to ask, what is intelligence to us? What makes up intelligence? What kinds of things could we measure to understand intelligence? And once we've decided that, we can actually develop something like an IQ test. You can quantify somebody's intelligence for certain abilities that make up that intelligence that you're interested in, and you can crunch a bunch of scores to give you some output that you can then use to understand someone's ability, how intelligent they are, according to your definition. Personality tests are the same. If you want to understand some facet of someone's personality, you can have a bunch of standardized questions on a personality test that would then allow you to understand something about that person's personality. So this is the part that's really important about psychometrics. So this area of study relies extensively on these types of tests, and especially standardized tests, because we want to have lots and lots of data. And by standardizing how we look at that data, we're going to get a better way of interpreting what that means for any one individual. So a lot of this area ends up being fairly model heavy or sort of calculation heavy or statistics heavy because we're trying to use pretty large amounts of data to try and understand what's actually going on behind the scenes with our abilities of interest. So what is it that's contributing to our intelligence? Or what is it that makes us a certain type of personality? Things like that. And just because I like having my explicit definitions when possible, when we're talking about a standardized test, these are tests. They're like the data collection technique where we're going to give an individual a test where they answer a series of questions, and we're going to collect a score. We're going to calculate either a score or multiple scores depending on the test itself, based on the responses that they give. And because it's standardized, this means that all the people who take this test are going to be given the same questions or the same types of questions. And we're going to know that based on certain abilities, they're going to respond in predictable ways. So we can actually calculate out their responses and compare those responses to our known distribution of scores. So with intelligence, we're actually going to talk about with IQ the fact that an IQ test is designed, and it's a standardized test, but it's designed so that the average individual will score 100. If somebody's score is higher than 100, we know that based on that score for this test, they are more intelligent, they have a higher IQ than the average individual in our population. If they score lower, they have a lower IQ than the standard individual in that population. So we have this sort of known expected type of score, and knowing where that individual falls within those expectations tells us something about them and that ability for that individual. All right. And again, we're going to see more of this when we go into our intelligence testing, when we start looking at our different models of intelligence, and then we'll do it again when we start talking about personality, where we talk about the scores that people have and then what it tells us about an individual and their traits, their qualities. All right, so if we're going to be comparing these individuals and their scores on a standardized test versus sort of our known expectations, our known distributions, we first actually need to be able to develop that test. We need to have a model where we can understand what's actually going on. So when we're developing a model, this usually involves hand in hand developing the test that allows us to sort of build up within that model. But we can talk about two main approaches. So when we're making a model, we can start with what's called a data-based approach, or we can start with what's called a theory-based approach. And again, this applies across different types of abilities. So this can be an intelligence test that we're building, starting with data or theory. This can be personality stuff with data or theory, either or, totally fine. But overall, our data-based approach is going to start with lots of data. So we're going to collect a ton of different data points. This is usually where we're going to have a bunch of tests. Each test is going to give us a measurement. So I want to measure how quickly someone reacts to something changing in the environment. So this could be something like when a red light turns on, I need you to click a button as quickly as possible. So that's your reaction time. So that is a single test that gives us a score, and that tells us then something about our ability to respond quickly. So that's maybe useful. Maybe that's part of something that we're interested in. We might also have another measure. Maybe we want to look at not just how quickly you respond, but how accurately you respond. I want you to respond to a red light, but not an orange light. Whatever we want to come up with. There's tons and tons of different tests we can do. I like behavioral tasks simply because of my own research, but this can also be stuff like I have a bunch of survey questions, and I'm going to ask you on a scale of 1 to 10, how much do you agree with the following statements? And I can ask you things like, you love to go out and hang out with people you've never met before, or you enjoy staying home in a space that's familiar, and all sorts of other questions like that. So we're going to ask a bunch of questions with no knowledge of how those questions go together yet. So we collect lots of data, and from those different data points, from all of our different scores, usually across as many people as we can get our hands on, hundreds or thousands if we're lucky, we want to start looking for patterns. Are there certain questions that people tend to answer similarly? So do we find that some people always answer that they're strongly agreeing to stuff like going out and meeting new people, or trying new experiences, or tasting new foods, things like that? Well, that's a pattern there. And when we start looking at those patterns, well, all of those things are related. Maybe that's something related to openness to new experiences. So that connects to some aspect of personality, and we'll actually find that that is one of our common dimensions within personality in one of our later chapters. But that's the idea here, is we start with data points. We start looking for patterns, and within those patterns, we can then try and understand what thing might be common to all of those measures. And then we look at how that connects to our larger ability of interest. So openness to experience is one aspect of personality from that example. All right, so that's the data stuff. Start with tons of data, look for patterns, label things at the end for how they relate to the larger ability. A theory-based approach is something that's probably easier to conceptualize. And this is because we start based on the theory. So we're going to look at our ability of interest. We can stick with personality if we want, and we're going to consider stuff that logically relates to personality. So what are some of the components that might make up personality? I've already talked about openness to new experiences, but maybe you think of things like how introverted or extroverted someone is. Maybe you care about how socially inept versus socially skilled someone is. You can decide what things you think logically relate to personality. And then once we've come up with a bunch of components that we think are important in understanding someone's personality, we can actually design a bunch of tests, a bunch of measures that would help us quantify those components. So again, we can go on our survey and ask, on a scale of 1 to 10, how much do you agree with the certain statements? And if we're looking at things like introversion, extroversion, we can ask, how likely are you to interact with someone new? Or how likely are you to not go and interact with someone? Preference for hanging out in a group versus alone, things like that. So you can actually, from your theory of these components are part of personality, actually design ways of measuring each of those individual aspects that would help us quantify those aspects or smaller components that build together to tell us something useful about their personality overall. And again, still weird because we're talking in abstract terms, but I do have an image that I've borrowed, And this one is talking about, these are specifically spatial abilities and academic skills. But on the left side with A, we actually have a more data-based approach where maybe we have a researcher who has gotten people to balance teacups on a spoon. So like, how well can you keep this balanced? So we get a score for that. We're also going to see how accurate they are at swatting flies in some computer program. So can you maneuver the mouse and click in the correct place while tracking a moving fly on the screen? So you get a score for that. We then also have a score for how well you can recite Shakespeare, maybe from memory or maybe while reading. And we have a way of quantifying your skill. Maybe it's number of mistakes you've made. We then can have summing numbers, so maybe accuracy in doing some math questions. So all of those are different measurements that we could make, and for an individual, we'd get a score for each and every one of them. So if, for our data-based approach, we're looking for patterns, we'd like to see which of these scores tend to be similar for an individual. So if you remember back to when we talked about our correlation coefficients, we said that if we're looking at the relationship between two different variables, or for us, two different measures, same thing, same idea here, these two variables, if they are strongly related, will have a high correlation coefficient. So 0.9 is a very high correlation coefficient. And what this tells us is that people who are really good at balancing teacups tend also to be very accurate when they're swatting flies. So they tend to do fairly well on these two sort of spatial awareness and physical type coordination skills. We then see that people who recite Shakespeare are also pretty good at summing numbers when we compare. They have another high correlation, which tells us the two are strongly correlated and specifically strongly positively correlated. And then we find, okay, so these two skills are related. Maybe that's something to do with what you need to do in school, so what you need to succeed in a school setting. But we can also then double check, are our teacup balancing skills related to our mathematical abilities? Well, that's a pretty small correlation coefficient. We're getting close to 0, which means that the two are not related. And then that tells us that our ability to balance teacups is probably not tied to our ability to do math. They're probably driven by two different things internally. And the same goes for any of these others. The blue things correlate with other blue things, but not with anything orange. And the orange correlates with orange, but not with any of the blue. So from that, we can determine that we have two different clumps where all the measures here must tie to some component that's related to some larger ability. So if we go back here, and we're saying that we collected a bunch of data, we had our 4 different measurements that we could look at. We looked at our patterns by looking at correlations. So we found that physical skills tend to correlate strongly, which means that maybe there's some underlying thing that makes us good at all physical coordination type tasks. And those 2 measures helped us capture that. We also found that our sort of ability to recite Shakespeare and do well on a math test were correlated strongly, which tells us that there's a pattern there. And there must be something that influences our ability to do those 2 things together. So that's the data-based approach. The other one here, the B on this side, it's still the same measures and still the same sort of divisions, but because we're going to say that this one is our theory-based approach, we're going to start by thinking about physical coordination as some ability that we're interested in. And then we'd say, okay, well, if somebody is good at physical coordination stuff, how can we quantify that? What kinds of things can we get someone to do to see if they are strongly physically coordinated? So we can get them to do balancing tasks, and they should score high on those if it's related to physical coordination, and they score high on other physical coordination things too. So if I'm trying to capture that physical coordination or spatial awareness or spatial abilities, whatever it is, we say, all right, they should be good at these types of tasks, swatting flies, balancing teacups, maybe things like throwing a dart at a dartboard. Those are things that they should score high on if we are conceptualizing coordination in a physical environment well. Same thing for the academic skills. We'd say, all right, there's some stuff that if you're good in academia, if you're good in school, you should be able to do well on these things. So we would expect that if you have good academic skills, you score high in Shakespeare, you score high in mathematics, and so on. And if you don't score high in one, you should probably score low in the others too. So we're kind of predicting these patterns based on that theory. And of course, you can test it as time goes on. Now, this is all still kind of giving us examples and sort of giving us the basics and an overview because I want to go into just a little bit more detail. Specifically, the data-based approaches are still fairly abstract from our discussion. Like, yes, I've talked about correlations and finding patterns, but that's not always enough for people. So I'm going to go into these in more detail. The theory-based stuff might already have sunk in, but I'm going to do it one more time later on just to make sure that we're all on the same page. But starting with the data-based approaches because they're a little bit more complicated. And as I said, we're going to start by measuring as many things as we can. So we're going to try and look at as many variables, as many different things we can get people to do where we'd get multiple scores for that individual. And we're going to try and stick to stuff that might be related to our ability of interest. So if I want to get some kind of understanding of personality, maybe I want to measure things like friendliness. So I can ask, when you encounter someone new, how likely are they to say that you are friendly? Or we could ask things like, when you encounter someone new, does the experience or does the encounter go well? Things like that, if we wanted to quantify friendliness. You can have all sorts of different survey questions, but I should have written down examples. We can also look at things like outgoingness. How likely are you to approach someone? Things like that. So those would be measures that we would try and capture. And you can get people to answer tons and tons of questions. We get all their scores for all of our different measures, so all of our different variables, and we can start looking at that data. One thing to consider, though, is that when you're doing a bunch of these tests, when you're doing a bunch of different measurements, well, some of these measures or some of these scores will end up being what we call non-independent. Now, when we're looking at understanding what contributes to some ability, we would prefer to understand all the different and separate components that make up that ability. At least that's usually the approach. So if we're understanding intelligence, we want to understand what is it that makes someone intelligent? What different types of intelligences are there? So maybe there's mathematical intelligence, but maybe there's also emotional intelligence, which we'll talk about later. So we'd like things that relate to one, but not the other. And so we'd like to design a test that allows us to capture only one dimension without sort of being messy and tying into other things. So when we start with a large data set with a whole bunch of different measurements that we've chosen because they're probably maybe related, we're going to end up with non-independent measures. So we can have two scores that are actually related to one another. They might correlate with one another because they're both driven by some underlying component. So, for example, our friendliness score and our outgoingness score, we might actually say that people who have more energy are both more friendly and more outgoing. So in this case, seeing those two scores where people who are friendly tend also to be outgoing, we could talk about that as somebody's overall energy. Maybe social energy would be how we'd label that. And that would be our sort of component of interest. So so if we're saying here that if those scores are not independent of one another, if we have that non-independence, then they're related to one another via some underlying component. So that energy level, social energy, might be driving both their friendliness score and their outgoingness score. And rather than trying to look at just friendliness and outgoingness completely separately, because we know they're now driven by the same underlying energy score, well, I'd like to try and understand energy as a product of both. So we can actually use statistical methods to try and identify these patterns where our measures overlap. And that actually allows us to then form independent. I was going to say not non-independent, but that's too many negatives. So we can use these statistical measures to put together independent sort of scores, independent calculations that allow us to use both our friendliness score and our outgoingness score to understand the more independent thing of social energy. And again, I have more examples. We'll get there in a second. So yeah, we're going to use these scores from all of our measures, and we're going to try and describe the underlying component that all of our different measurements are coming from. So we want to try and use our statistics to boil everything down, to get rid of all the redundancies, to get rid of all the overlap between the stuff we've measured, and get a single score that is going to come from all of those together. So the most common way that we'll do this is something called factor analysis. Now, this is a statistical technique that's going to take our large set of our non-independent measures, our large set of data that we got from measuring a ton of different things, and this technique allows us to collapse that larger set into a smaller set of relatively independent clusters or factors. So that's what we're talking about here, where if we wanted to understand the pattern between friendliness and outgoingness, and we can look at those patterns and get something that would independently be called our social energy, we'd use a factor analysis to do that. Of course, just having two things and collapsing it into one is way simpler than what you'd usually use a factor analysis for, but it's a good way to conceptualize it on a small scale. But yeah, so our factor analysis is going to tell us that we have a couple of different clusters that are going to have variables or measures that correlate highly with one another. So we score high on friendliness, we score high on outgoingness. Those are all part of the same cluster. They're part of the same factor. And that tells us that social energy is what that factor is. And we use what we understand of our friendliness score and our outgoingness score to make up that factor. And we can then calculate a score for just that factor using all of the different measures that we already had. So each of those clusters has those variables that are going to correlate highly with each other, but they're not going to correlate strongly with other variables that are going to be in their own clusters. And this seems really weird. Why do we care if we can get variables or measurements that cluster together? Well, that's focusing on, That's focusing on the fact that if we can calculate this independent feature, this independent factor, then it's going to allow us to sort of make some inferences about the underlying characteristic that we're guessing is accounting for all of the different links between all of our different variables in that cluster. And that's a little awkward in terms of wording. So I simplified it into saying that each cluster can be thought of as a single aspect of the ability we're interested in. So that social energy as some component that makes up our personality is what we're trying to get at here. And we can understand social energy levels when we look at our different measurements that we can collect based on friendliness and outgoingness. So we're taking multiple scores, collapsing them into smaller and more useful scores that we can relate to some overarching label. So that social energy is the label that matches with the different things that are all combined within that particular cluster. For a non-personality example, for intelligence, we actually see clusters related to things like, say, memory. So we have a cluster that we can call memory. So people who are good or score high in memory overall are going to also score high in measurements for visual memory as well as auditory memory. So they're good at remembering stuff from different types of tasks that would test memory abilities. So we can have those multiple different measurements. So maybe we get somebody with a bunch of flashcards and we get them to play a matching game using visual stimuli. Maybe we get somebody to listen to a story and then test their recall. Both of those are different tasks that would give us a score, a measurement score for each of those tests. And then we could crunch them together to give us an overall idea of how they score for memory as a cluster as a whole. So we can use those multiple measures within a cluster to get a single score rather than multiples that we can then interpret and relate to intelligence overall. And again, still kind of weird and abstract, but one more example with some visuals, and then we'll tie it back to this example once again. But here we are looking at a very, very small set of variables or measurements. So in this case, we've measured 6 different things. So these are all going to be different tasks that we've had an individual complete. And maybe we got 100 people to do all 6 of these different tasks. And what it tells us here when we're interpreting this, where I'm using the example for the first 3, I'm not coming up with examples for the others because it's fine, we'll get it from this. But for our first task was looking at throwing a dart at a dartboard. And maybe we would give them a score based on how close they get to the middle of the dartboard. So scoring high on the dart throwing is that you're very accurate at that particular task. Maybe task 2 then is getting you to catch a ball. So maybe we're going to look at how many times in a row you can throw a ball and catch it without dropping it. Then our next task is, say, keeping your balance on a narrow beam. So maybe we're going to bring a bunch of people into a gymnasium. We're going to roll out a long, thin piece of paper that's, I don't know, like 30 centimeters wide. And we're going to get people to walk 1 foot in front of the other as far as they can. And as soon as their foot comes off of that 30 centimeters, then we have to look at how far they got. The further they got, the better their balance is. And if those are our 3 different things, when we look at this diagram down here, these are actually going to be correlation coefficients. Now they've specifically made them all positive just so it's easier to look at, and that's great. This also works magnitude-wise for negatives. A strong negative correlation is still really important to know, and is then can be part of a cluster. So if one of these was like, say, negative 0.8, that would still be part of the cluster. It just means that one score meant that scoring high is good and scoring low is bad, and the other does the opposite. But it's all about framing, so we don't have to worry too much about that. But we interpret this here, where if this along the top here is the 6 different tasks we got them to do, and then this is the same 6 tasks so that we can look at the intersection between them. So you'll notice along this diagonal, we have all ones. And the reason for that is their score on test 1 is going to be the same as their score on test 1. An individual score, it's going to match because we're just looking at how their score always compares to itself, which is it's always perfectly related. Once you know their score, you know their score. So we just ignore this. This is just telling us, yeah, there's nothing weird going on. We also don't need the bottom part of this chart filled out because if we look right here, we have a correlation coefficient for the individual score on test 1 and their score on test 2. If we went here, this would be their score on test 2 compared to test 1, which is exactly the same thing. So we don't need that redundancy, so that's why that part of the chart is empty. So all of that is just sort of helping you orient as to why we ignore all the ones and we ignore all the empty space. But now what we care about here is this score, this correlation coefficient, is going to tell us that an individual that is very accurate at throwing a dart tends also to be accurate at catching a ball, or they tend to be able to successfully catch the ball more for longer periods of time or for more throws or whatever. So they tend to score well on both. It also tells us that if you score poorly on one, you tend to also score poorly on the other. That's just what a correlation is. They're positively correlated. as one increases, so too does the other. We then also see that this individual, score 1 versus 3, if they're good at dart throwing, they're also good at keeping their balance. Those also correlate fairly strongly here. And if we then look at 2 versus 3, if they're good at catching a ball, they're also good at keeping their balance. So all of those are really strong correlations. And if we look at all of these abilities, when we say, all right, this is our cluster, what do all of these tests, what do all of these tasks have in common? Well, they're all related to some kind of physical spatial ability. So maybe we're going to call this factor our spatial skills. And maybe it has some kind of relationship to spatial awareness, I don't know, whatever we want. But because all of these have that spatial ability or spatial skill in common, that's what we could call this cluster. So based on all of those tests that we gave, we found that these ones are closely related to one another. Their scores tend to match up nicely. We see a pattern, and therefore we can put them together. So while all of these scores are falling under that single factor or single cluster that we're calling spatial skills, we use the measurements from a bunch of tests to make that determination. So we started with 3 and we've collapsed it down into a single factor or a single cluster that we can then look at in the future. And we'd also want to look outside of that. So over here, it's like, well, what about test 1 and test 4? Are those two scores related? Maybe test 4 was the reading Shakespeare. Well, that's not a really strong correlation coefficient here. 0.46, somewhere in the middle. It's not as strong as these ones here, so we'd say that's probably something unrelated. As we go across, 0.39, even less of a strong correlation. So we're getting weaker. That tells us that task 5, whatever that one was, doesn't relate to 1, 2, or 3. And we can sort of look at these patterns here where none of these are really high numbers. So that tells us that while tests 1, 2, and 3 were all kind of related to one another, the scores are all showing a pattern. 4, 5, and 6 do their own thing. And when we look at the comparison between test 4 and test 5, we again have a pretty strong correlation, which tells us 4 and 5 are going to be probably related. 4 and 6 are also really high. That tells us those two are correlated with one another. And 5 and 6 are also related. So that identifies a second cluster. And if this one was our spatial skills, and I hinted that maybe 4 is reading Shakespeare, then maybe this is verbal skills. If we were looking at ability to recite Shakespeare versus read and interpret a poem versus some other literature-related thing. So that could be our verbal skills here. And we, again, see that these are all strongly correlated with one another, but not with anything else. So we know that they're independent of one another. So we took 4 different things, or we took 6 different tests, looked at those scores, and collapsed 1, 2, and 3 into a single factor. And then we also collapsed 4, 5, and 6 into their own separate factor. And now we have 2 different factors or clusters that we think are related to our spatial abilities, as well as our verbal abilities. So that's how we can take lots of complicated and interconnected non-independent scores and turn them into more useful and relatively independent scores that we can sort of collapse those into. And that's where we got over here, where we were looking at those correlations between this score, and that high correlation tells us they're likely related to one another. That's what this factor analysis was doing, just represented in a slightly different way, where here you get to see the arrows that show you what we're looking at those correlation scores from, just to give us a better idea. And then, of course, I did say that I do theory-based. Once again, even though it's a lot easier to grasp, here we are considering all of the different aspects that might make up that ability of interest. So we're going to ask ourselves, what do we think actually contributes to something like our spatial ability? What contributes to our verbal abilities? Maybe we want to ask what makes somebody spatially aware. If we're looking at those spatial abilities, what things might we want to measure to give us an understanding of this ability as a whole? And then we're going to say, how do we actually test each of those aspects? What questions could we ask, or what kinds of behavioral tasks could we do? Things like throwing a dart at a dartboard, throwing and catching a ball to measure how long you can do that accurately. Those are all different tests that we could pick from in order to try and quantify what relates to our ability of interest. So there might be existing tests that we can use that would measure it. So maybe there's already a standardized set of questions out there that measure something like day-to-day happiness or patterns of friendliness or whatever it is we're interested in. Or we can design a new task. So I want people to throw and catch a ball in this particular setting because that's easy to do. I've made up something new that doesn't really need all the complexity of an existing standardized test. And some people would look at this and say, well, if we've stressed how important it is to have those independent factors from our data-based approach using our factor analysis, why would we use a theory-based approach? The reason is that it's actually not always possible to measure all the different aspects that we think might contribute to a given ability of interest. So if we think about intelligence, there's going to be stuff that our tests are not able to measure. Maybe there's stuff we can't design a test for, or maybe we haven't yet designed a test for it. In those cases, we've said that, all right, we might have an idea that these types of abilities would go along with this, that they would be related to this, but it's not always possible to measure the data to do that confirmation. So theory-based approaches are going to be used in cases where, say, we have an idea of what an ability is, and maybe it's hard to quantify, or there are some kinds of limitations. This can also be a starting point, and of course, in the real world, when you're doing this in practice, we tend to, say, start with a theory and then do a bunch of measures and then run our factor analysis and then refine. That's always possible too. So it gets a lot muckier and murkier and more overlapped between the two types of approaches in practice. But we talk about them separately because they do have distinctive qualities. They start from different places and they're sort of built either from the ground up or from the theory down, depending on what information we have available and how we want to work with it. So we talk about both separately and then just acknowledge that in practice, it's probably not as clean cut as this for sure.